Welcome back. We're going to continue our work with Riemann sums. This example, we're going to break it down, the process of writing down a Riemann sum. We're going to break that down by first sketching a graph of the function under consideration, taking time to calculate delta x, the width of each rectangle, and even talk about the grid points, the left and right endpoints of different subintervals and such. Then we'll calculate the left and right Riemann sums. And just to remind you, each Riemann sum, including the midpoint Riemann sum, is a sum of products. One factor is the height of a rectangle, f evaluated at some x bar on each subinterval k, times the width of the rectangle, delta x, and then we add up in terms, and that we have that counter k. And this is an approximation of what some people call the area under a curve. And for this example, we're going to let f of x be the transcendental function cosine of x. The closed interval will be negative pi over 2 to pi over 2. So that's a and b. And we're going to create 4 subintervals, so n is 4. Okay, let's take a look at the, well, kind of a rough graph of cosine. We know cosine is periodic, but from negative pi over 2 to pi over 2, the outputs for cosine are all positive, and so in red I've shaded in the area bounded by the curve cosine of x and the x-axis. Okay, so the length of this interval from negative pi over 2 to pi over 2 that's a total of pi, and so when we're calculating delta x down here, we take the difference of those endpoints, which we get pi. We'll divide that by 4. So delta x is going to be pi over 4. And if we want to talk about our grid points, the first grid point would be a itself, negative pi over 2. Then we move over a total of delta x, which will move us to negative pi over 4. X sub 2, we move again, a total of delta x, which moves us to 0. The third grid point we move over again to pi over 4. And then the fifth grid point, which gets us to the end, is pi over 2. Recall that n was 4, so I made a mistake there. I needed to label that x sub 4. And if you have 4 subintervals, you'll have 5 grid points, and x naught would be a, and x sub 4 would be b from the original interval. Okay. And if we want to look at the left Riemann sum in the picture and how it would be an estimate of the area under the curve, on the first subinterval we would use the left endpoint, evaluate cosine at negative pi over 2, which would give us 0, and the height of that first rectangle would be 0. For the second subinterval, we'd use the next, we would use its left endpoint. Evaluate cosine. Cosine at negative pi over 4 is square root 2 over 2, and we use that height for the second rectangle. The third interval, we use the left endpoint, which is 0. Cosine of 0 is 1, and we use a rectangle with height 1 for the third rectangle. And then for the fourth subinterval, we use the left-hand endpoint, pi over 4. Cosine of pi over 4, square root 2 over 2, and that would be the height of our rectangle. And when we're using the left-hand endpoints as a height, if the function is increasing, we'll have an underestimate of the area, and wherever the function's decreasing, we have this overestimate. So in this sketch, 1, 2, 3, 4 rectangles to estimate the red area. It's a rough estimate. Notice that one of the areas is actually 0, and 2 of these areas were the same, and the rectangle with the most area was where the height was cosine 0 or 1. Now we're going to do a second calculation, so I thought I'd bring that picture out again. When we end up doing the right Riemann sum, for each of the 4 intervals, we'll pick the right-hand endpoint, evaluate cosine, and that'll become the height of our rectangle. And so we first have an overestimate. Second interval, right-hand endpoint, cosine of 0 is 1. Again, we have an overestimate. Third subinterval, right-hand endpoint is pi over 4. The height of cosine is square root 2 over 2. Same as our first estimate over here. And then the fourth interval, cosine of pi over 2 is 0, and that's where we end up getting a rectangle of height 0. Did you notice that our estimates are going to be the same? It's kind of like a mirror image, left and right hand endpoint approximation in this example. Okay. Now let's turn to some calculations. We've sketched the graph. We've calculated delta x, and that was going to be pi over 4. We've looked at the grid points. We've illustrated the sums, but now we want to calculate the sums. Okay, let's do the left sum. Okay, a is negative pi over 2, b is pi over 2, n is 4, k is our counter. Delta x, remember it was pi over 2, take away negative pi over 2 for a total of pi, divided by n, which is 4. So when we formulate x bar sub k, we always start at a, which is in this case negative pi over 2, and we're going to add the difference k minus 1 times delta x, in this case, which is pi over 4. And then we want to evaluate our function at this x bar, the left-hand endpoints of the subintervals. Our function in this example is cosine of x. So it's cosine applied to x bar, which is the sum, negative pi over 2, plus the difference times pi over 4. And now we have the pieces of the puzzle. Our left Riemann sum is the sum, k equals 1 to n, which in this case is 4. The heights of the rectangles are cosine evaluated at the sum above, up here. But we have to take that whole factor times delta x, which was pi over 4. Okay. And so we have set up the right Riemann sum, and we could use technology, and should probably use technology to calculate that. Okay. I'm going to leave that part there and turn quickly to the, let's move that on up, the right Riemann sum. We have the same delta x, pi over 4, but we need to reformulate how we choose a value x in each kth subinterval. An x bar this time, again we'll start with negative pi over 2, but we're going to add k copies of delta x. So it looks a little simpler. And then when we evaluate f at x bar sub k, we're applying cosine to this new sum. And so for the right Riemann sum, it's going to be a little bit different than the left. We'll have cosine of this new sum, negative pi over 2, plus k pi over 4 times pi over 4. And we can compare that. Oops, I'm off the screen. Sorry guys. Let me move. Get the paper to move here. We can compare the left Riemann sum above to the right, and they just differ in the multiple of pi over 4 that we're adding to a. Thank you.